first one. How many peptides, one kind of MHC molecule can bind how many peptides, how many kind of peptides? One MHC molecule, not one kind of MHC. How many MHC molecule has on the surface of a dendritic cell? Millions. Okay, millions. These millions MHC molecules, how many peptides can be presented by these million of MHC? How many different peptides? One. One is for sure not good. By million MHC. We said that the MHC molecule can present self and non-self peptides. Yeah, simultaneously at the same time. So the question, how many? One is enough?
No.
So let's see an example. Okay.
Speak English, I understand.
So we have a peptide, it's 9 amino acids written there. Okay? If my MHC molecule can present only this peptide, what will do the virus? What will be the strategy of the virus? Change the peptide, do a mutation. Okay? And if it's mutated, my MHC cannot present it. Okay, so it's not good to present only one peptide. The MHC molecule must present more than one. The question, can the MHC molecule present any peptide, all the peptide? No, it's technically hard. Yeah. So what is the strategy of the MHC? The MHC one will choose a few amino acids, mostly the first one and the last one. Okay? These two amino acids must be isoleucine or alanine. Yeah? All the others are indifferent. So we can change here. We can here XXX. So how many peptide will it? It's about one kind of MHC can present around 10,000 different peptides. Okay, not all the peptide, but a lot of peptide. Is it okay? What will be the strategy of the virus in this case? Change, but where will induce mutation the virus? The virus can induce mutation in all the position, yeah? But the virus will select it in my body. Which virus can survive in my body?
Which change the first one.
Which change this letter, yeah? Or this one. Okay? So virus can do it. Yeah? And still, if my MHC molecule cannot present it, T cell cannot recognize, cannot kill the infected cells. Okay? What can we do? Because the virus can do it. Okay, what is the optimal solution against the virus?
Excuse me, can you explain again?
So that's lexically what you must know, that one kind of MHC molecule can bind several peptides, about 10,000 different peptides. So not only one, not all the peptides, but several. Because out of the 9 amino acids, only 2 is important for the binding. Okay, the first one or the last one. Is it clear? Okay. But the virus can mutate it. Can induce mutation in the critical position. If the peptide is mutated, then the MHC cannot present it, so the virus can survive in the human body. It's okay. So what is the solution? What do you think? To repair the projector, okay. What else? We need more than one kind of MHC molecule. Okay? We have another MHC molecule which requires tyrosine and require uracil or anything. Yeah? So one human cell will express more MHC molecules. Okay? Not only one kind, but 6 kinds. Okay? 6 different MHC molecules will be on the surface of all the human cells. Okay? It's clear. To present more peptides, six different MHC molecules can present how many peptides? One can present 10,000. 6,000. Why it's zero? One MHC can present 10,000 different peptides.
I'm confused.
Confused?
Yeah.
One MHC molecule, one molecule can present one peptide. It's clear.
Yeah.
One kind of molecule can present 10,000 different peptides.
Mm-hmm.
Yeah? 6 kind of MHC molecule can present 6
60,000.
10,000, 60,000. Okay?
Right, okay.
Okay. So that's the strategy. How can so here this moment I told you that we have one kind of MHC molecule, but we have 6 kinds. How is it possible that on the surface we have 6 different proteins? All this protein is MHC1, but we have 6 different. How is the genetic? That's the current topic. Combination, that's good. That's good word is the combination.
So there's a subgroup of MHC1?
If I have, what, do you know the name of the genes, MHC genes?
Yeah.
What is the name of the gene?
HLA. Yeah.
Human leukocyte antigen. The protein is the MHC protein, the gene is the HLA. If we have an HLA gene, how many alleles does it mean? Must be 2, yeah? One paternal, one maternal. So I have paternal and the maternal. If the 2 allele is different, yeah, paternal, maternal, then on the cell surface can be 2 different proteins. Okay. How call we this when the two genes are not the same, the 2 allele? Heterogeneous, okay, and in the population? What was the word? Polymorphism. Okay, polymorphism, it means that in the population there are variations, a lot of different variations. Okay, so the MHC molecule are absolutely the most polymorphic in the human, extremely polymorphic. Okay, we have 10,000 variations at least. Okay. Okay, to wake you up. Have you ever heard about the stinky t-shirt experiment?
Stinky?
Stinky t-shirt. So it was done as quite simple, just sweat t-shirt was given to the other gender to smell it. And was asked that, do you want to couple to go with that guy or not? Yeah. So the test was an applied test. Nobody can see the person, only smell the t-shirt. What do you think? Who would you change? Who would you choose by the smell?
Yeah.
Which is the good strategy, evolutionary? No, it's not smelling. It's a good. Who you feel like as a good.
You mean pheromones?
Pheromones, yeah. But who genetically? Who is the best partner for you?
Also aggressive.
Who is genetically not comparable with you? Who is very far from you genetically? Yeah. The most difference, the better for you.
Yeah.
Yeah. So you choose a person who is very far from you. And how do we know that the person is not genetically very far from me?
If I don't like this.
No. Genetically means that we must choose a polymorph gene. Because in the actin, this protein is the same in all the person. Cannot be polymorph, genetically all of us is the same. Yeah? But the MHC molecules are absolutely different in all the humans. Okay? And based on the difference of MHC molecule, we can tell that we are comparable, we are similar, or we are completely different. Okay? So by smelling, we can tell that you have the same MHC molecule or not, like me. Okay? So it's physically, it's proved that human use it. Okay? So you can smell your partner. How is the MHC? Okay. What do you think? What will be the strategy of a pregnant woman? So normally we choose as a partner who is very different than me, very far from me. What is the strategy of a pregnant woman? Choose the similar. Okay, the husband cannot help you for sure, but the mother, grandmother, and the family can help you. Okay, so the pregnant woman change the smelling. The husband will be stinky, and the family will be good based on the MHC molecule. Okay, choose the similar. Choose the family. Okay, so that's one advantage of the polymorphism. So till this moment, we are there that the MHC molecule is polymorph. So we have two different proteins on the cell surface. Okay, one maternal, one paternal. But I told you that we have 6 different proteins. How can we do it? One gene, one protein. How can we increase the number of the proteins? Increase the number of the genes. Okay? So we have 3 genes in the chromosome: HLA-A, HLA-B, and HLA-C. Okay? These 3 genes will produce MHC1 molecules. Okay? And we have maternal and paternal, so 3 maternal, 3 paternal protein is expressed on the cell surface. Altogether 6. Okay? So all the human express 6 different MHC proteins. Okay. All the genes are very, very polymorphic. Okay? So we have 10,000 different A, 10,000 different B, and so on. The number of the possible combination is 10 to the 15, based on the allelic variations and based on the genes. The number of the humanity is 10 to the 10. So 10,000 times more possible combinations we have than the human. Is there 2 human who has absolutely the same genes?
Some forms of twins.
The identical twins. If the genetic background is the same, then the proteins will be the same. Okay. So you should memorize 2 things. Okay, 3. At first, one kind of MHC molecule can bind not only one peptide, not all the peptides, but several peptides. The second, the MHC gene is polygenic. So we have 3 genes. That's what we call polygenic. And the MHC alleles are polymorphic. In the population, we have a lot of variation. See? So polygenic, polymorphic. It's clear what does it mean. Yeah? Okay. Don't mix it. What was that?
You said
The peptide, the number of the peptide. So one MHC molecule can bind more than one peptide, but not any peptide. So how is it in the case of MHC2? Till this moment I spoke about MHC1. You know everything about, every important things about MHC1. How many protein bind the peptide in case of MHC1? That was a question in the test. How many protein bind the peptide directly?
Which peptide?
One. What's the name of this protein?
Who was that?
In case of MHC, with only the alpha chain bind the peptide. Okay. In case of MHC2, alpha and beta chain. So in MHC2 we have alpha and beta chains, and we have maternal alpha and beta chain. Okay. Sorry. So the name of the MHC, the genes are HLA, DP, DQ, and DR. Okay. So we have 3 polymorphic genes encoding the MHC2 molecules. But we have polymorphic alpha chain, polymorphic beta chain, paternal, maternal. Okay, so let's see what happened in the ER. The alpha chain and the beta chain are synthesized simultaneously. together? No? How is it?
One by one.
One by one, and who will connect the two proteins? The invariant chain. Okay, so we have alpha chain is synthesized here, beta chain is synthesized here.
Excuse me, if you switch off the lights, I think it would be more difficult. Yeah.
I don't know, it's something here, but I can't. It will go, but just for a few minutes. Okay, so in the ER, paternal alpha chain is synthesized, maternal alpha chain is synthesized, paternal beta, maternal beta. The maternal beta can couple with the paternal alpha. Why not? Yeah, it's just an alpha chain. Of course, the protein doesn't know that I came from the father or I came from the mother. Yeah, so we have combinations. Okay, so the MHC molecules are different on the cell surface because the MHC, the gene is polygenic, the allele is polymorphic, and in case of MHC2 molecules, the chains can combine to each other. Okay, so 3 different ways to produce more kind of MHC on the cell surface. Okay, just memorize the 3 ways. Okay, the function is clear. Yeah? To produce more than one kind of MHC molecule.
Excuse me, what was that?
DR, that's, so DPDQDR is the name of the genes of MHC2. 3 gene code MHC2. So, yeah.
Is the invariant chain also a factor?
No, invariant chain is invariant, the name.
Yeah, what the
Is
function
it important for?
It can, the invariant chain will bind the maternal paternal alpha beta.
But can it do maternal
I can do the maternal of
So that's one of the
yeah.
factors that affects the.
Yeah, there are a lot of combinations. So we don't know how many MHC molecules, how many different MHC2 molecules are on the cell surface. It's between 15 and 20 in one person. Okay, we have all the human express 6 different MHC1, and the human express 15, 20 different MHC2. One important question, in my body, the cells will express the same MHC molecules. All my cells, all my nucleated cells express the same MHC1. Must be, yeah? Not should be, must be. Because the genetic background is the same in all my cells. So just to summarize it once more. I press it something. So imagine the situation, what is on the human cell surface? Okay, I have one paternal HLA-A, yeah? We give a number for in the clinics. Okay, so I have the 3022 for paternal. I have a maternal HLA-A, the number is 200. Okay, I have maternal B, the number is 10. Okay, so there are a lot of variations, and on the surface of my cell is written a very, very difficult code. Okay, 30222001238, yeah, anything. And my immune system go there and check this number. This ID number is written in the surface of all my cells. And the immune system recognizes, okay, it's a correct ID number, it's my cell. You can live. If there is this number, if only one number is not correct, the immune system will kill it. Okay, yeah?
What happens in a graft of the host rejection?
Okay. So that's the next point. Why is it so important? What is the consequence of it, that we have different MHC molecules? There are 2 extremely important consequences. The first one is the infections. Okay? So, or have you heard about the personal therapy? No.
Personal therapy.
No. Okay.
Personal therapy, spa.
Okay. So, what will happen if I infected by an influenza virus? The virus is very clever and mutate the critical position. I will be sick. I come here and infect you because I'm a so good teacher. What will happen in your body? In your, not in mine, but in your body. What will happen? So the virus
Will detect you.
mutated the critical position for my MHC.
So your MHC will
No, the virus will infect you, not my MHC. But your MHC can present the virus. Yes, can, because you have different MHC. Okay? So that's one reason, one consequence. That the population, if it's polymorphic, the population will be safe, for sure. I can die, but you will not die. Okay? So there we know that there are a few percent of the humanity is resistant to the HIV. It depends on the MHC molecule. They are very lucky. They can present very well in extremely good the MHC. The HIV cannot be infected. How is it possible that 20% of the humanity is allergic? 5% is allergic to any pollen. Why is it? They have too good MHC to present the pollen, and the immune system believes that it's an antigen. But the other 95% are lucky with another MHC will not present. Okay? So the personal differences is mostly due to the MHC. Okay? That's the first. Okay? So personal differences is due to the polymorphism of the MHC. The second, what is the problem with the transplantation? If we put a tissue of the donor to the host, what will be the immune reaction?
It depends if immune suppressed or.
How can the immune system recognize that is not my tissue? That is your tissue. How is it recognized? By the MHC1, because you have different MHC1 than me. All of your cells express different ID number than my one. Immune system recognize it. Okay. So, can you tell me? We spoke about it, that one T cell can recognize one MHC peptide complex. Yeah? What will happen if we change the peptide? Can this T cell recognize it? No, not this one, some other. What will happen if we change the MHC1 molecule? The peptide is the same, but with different MHC. This T cell cannot recognize it. Other T cells, yes, can recognize. Okay, that's the problem. That in our body, I have a lot of T cells which can recognize your MHC because it's not my one, it's a foreign molecule. Okay? So that will be an extremely intense reaction against your MHC molecule. So, due to the MHC polymorphism, we have personal differences and we have tissue transplantation or tissue rejection. Okay. One more thing concerning the MHC molecule. Okay. So, till this moment I spoke about T cell MHC connection. We have another cell which can recognize the MHC molecule, MHC1. Which cell can? Which cell is still regulated by the MHC? Natural killer cell. Okay. So what will happen with the natural killer cell? That's the next question. How is it? Natural killer cell. So it's mainly for the ladies. What will happen in the baby, in a pregnant woman? How will be? how will be the expression of MHC molecules on the babies? Maternal, paternal, both. 3 paternal, 3 maternal, yeah? So we have ABC maternal, ABC paternal. How will react the mother, the immune system of the mother against the paternal genes?
It will not.
Why not? It can recognize. All the T cell recognize that it's paternal, it's not me, kill it. How can we protect the baby? There is one way to protect. Just mask, which means that the trophoblast cells do not express MHC1. Okay? What will happen? What will do the NK cells? If there is no MHC1 on the cell surface? Kill it. Okay, so that's a problem. That's a real problem. A lot of, what is when the pregnancy is finished? Abortive pregnancy is due to the NK cells. But we have, the solution is that we have non-polymorphic MHC molecules, HLA-G and HLA-E. Non-polymorphic is same in all the human. Okay, so the trophoblast will express not HLA-A, B, C, but HLA-G and E. Okay? This molecule is just to block the natural killer cell. Not to present for the T cell, just to block the natural. It's clear, yeah? Okay. Oh, sorry, one more. I still have 5 minutes. It's in your life, okay? It's not for the test, in your life. So we have, if you can survive, then it will be important for you. So we have maternal, paternal genes. What do you think, what is the chance that the 2 brothers has the same pattern? So I inherit absolutely the same MHC molecules as my brother. Is it possible or not?
Yes.
We are not identical twins.
No,
Can we calculate?
Yes, we can calculate. So that's the background of the mother, that's the background of the father. Okay? What kind of molecules will be inherited? One from here, one from here. Okay? The trick is that these genes are linked, closely linked. There is no recombination. Okay? So it will be inherited in one group. Okay? So it means that we have chance to get a black with green or a black with blue. Yeah? There is no more passive, and of course there is the red with green and the red with blue. Okay? So it's clear? No more possibilities, only 4. So if you need an organ transplantation, who would you choose as a donor? The more closer, the teacher. So, how is the similarity with the parents? How is the similarity with the parents?
Could be from mother or father. Wrong.
So it is different under the
It's all the same. The mother and the father has 50% similarity.
Oh.
So the parents are not too good donors, okay, because the similarity is only 50%. But how is with brothers?
Maybe.
You have only 24 different possibilities, so you have relatively high chance that your brother or sister has absolutely the same background as you. Okay, so just by chance you need an organ transplantation, try your family. Okay?
So if there are 4 possibilities, it means like the chance of having the same.
25% that you have absolutely the same.
Yeah, it's only 25.
It's only 25.
You said 50% for the parents.
Yeah, no, 25% that you are absolutely the same. Okay? If you have 10 brothers, one of them will be correct.
Already have.
Hmm?
Already have.
Yeah, that's more important.
Only.
Already have them, brother.
Okay. So it's existing. Before transplantation, we can check the genetic background. You must ask it. They will do. There, you can find an optimal donor. Okay, that was the message of this part.
Is this going on the test?
Yeah,
Is this coming on the test?
it can be. Check the slideshow. Yeah.
Slideshow, okay.
Excuse me.
Yeah. Tell me.
Where is that tendency?
That's a good question.
That's important.
Just get it from some tendency. Ama öncekiler arıyor ama just İtalya'ya
Are we going backwards?
new stuff to do, man.
50 minutes?
Okay. So I finished MNC. You should still be here 10-15 minutes, no more. Okay?
Okay.
Sure. Okay. So we should speak about the if I can speak. So we should check the mucosal immunity. Mucosa is a surface where most of the pathogen enter to the human body. Yeah. It has an extremely difficult immunity. We don't know it exactly how it works. At the first seminar, I told you about the commensal bacteria flora. Can you remember that we have huge amount of bacteria? What is the best strategy of the immune system if we have huge amount of commensal bacteria? It's all the time there are a lot of bacteria. All must be very tolerogenic, yeah, to block the activity, because there are commensal good bacteria, don't kill them. So the first feature of the mucosal immunity that is tolerogenic, very, very suppressive. All the time produce a lot of suppressive cytokine. There is a trick again, and it's very difficult, that's why we don't know how is it working exactly, because there are a lot of bacteria. These bacteria will stimulate the immune system all the time. Okay, so in the mucosa, we have a tolerogenic immune system, suppress the immune response, but all the time we have immune response. Simultaneously. Activity, suppression. Okay, so that's why it's a bit too difficult. So that's first, it's a tolerogenic area. Second, it contains some special cells that you should know. What is the role of the goblet cell? Goblet. What is the role of the palate cells? Palate. Okay. What? It secretes antibacterial proteins. So all the time. So all the time in the lumen, we have biologically active molecule to kill the bacteria. And what's the role of the microfold cells, the M cells?
Presentation.
It's transport. Yeah? So it grabs the bacteria in the lumen and transport it to the other side and give it to the dendritic cells of the macrophages.
Presentation.
It's not, okay, it's not, just don't mix it with the classical antigen presentation. It's just transport. So it grab an intact bacteria, transport it, and give an intact bacteria. Okay, don't modify the bacteria. Okay, and probably that's the last. Check the slideshow, I didn't tell you all the detail, okay? And read the test. That will be in the test. Okay. One more important thing. What is the role of the IgA molecule? Protection in the mucosa. Okay? And how can it protect the mucosa? IgA is a dimer. What is the immunological function? To neutralize. Okay? The IgA cannot do anything else but neutralize. How can the IgA get into the lumen? The intestinal lumen.
There's a lot of plasma cells there.
But plasma cells are not in the lumen.
No,
You missed here 5 minutes in a quiet way.
laminar copy.
Yeah, so the plasma cells are below the epithelial layer. How can the IgA get into the lumen?
By passing through the alkanes.
We have a special receptor.
Receptor from the alkanes.
It's a poly Ig receptor. Grab the IgA here, transport it and release. Okay? And why is it that the plasma cells in the intestinal tract produce IgA? How is it possible? Why not IgM? Because you know about the isotype switch.
Yeah.
Okay? The isotype switch is directed by the dendritic cells below the propria,
Yeah.
and these dendritic cells secrete cytokine to help the plasma cells to switch to IgA. The second, what kind of lymphocytes will be here? No, not too much. Believe me. What kind of lymphocytes?
Regulatory T.
Naive lymphocytes. All the time the immune system is activated.
Regulatory. Regulatory T cells.
There will be regulatory T cells, okay, a lot of regulatory. But what else? So all the time the immune system is activated. Will be there naive lymphocytes or memory?
Memory.
Okay.
Memory T cells.
So the mucosa is full with memory cells. Okay, memory B cells, memory T cells. How can the memory cells come in this tissue? So we have a naive B cell, recognize the antigen here, start to proliferate in the lymph nodes, in the mucosa. What will be the next step? From the lymph node, the lymphocytes can get to the no. From the lymph node, you cannot go to the tissue. To the blood. And from the blood, how can you know that it's a mucosa? Why will you get to the intestinal tract and not to the kidney?
Because of the zinc.
Because chemokine receptors, selectins integrate. So the mucosa has special chemokine receptors. And how do these B cells know that I have to come here? Why start to express this chemokine receptor? That's a very simple way. Okay, I cannot ask it. The dendritics, all the time, that's my last 2 sentences, okay? So in the intestinal tract, we have all the time food. The food has a lot of product, for example, the vitamin A. If the dendritic cells sense the vitamin A, then produce special cytokines, and these cytokines induce the chemokine receptor on the B cells. Okay? So the food, the vitamin A will direct, the product of the vitamin A will direct B cells here.
It's really hot.
What?
No, isn't it?
Not bad.
Thank you. Even, I mean,